In this video, we will show you how to create a digital twin of a shipping lock. The lock is located in the Netherlands and includes a drawbridge, footbridge, and roll bridge. First, we create the dam between the lake and the sea. A concrete texture is applied. Next, a drawbridge is created with a built-in solid modeler. It has a parameter that specifies the angle of the bridge. A traffic light is created by subtracting cylinders. This traffic light is included as a part in the lock light. If then else statements set the colors of the lights based on the light status: stop, prepare, or proceed. The door of the lock is created by extruding a profile. A fence is added using a repeat statement. 4 instances of the door are included in an assembly of a door set. The angle is defined as a parameter. All components are linked to topics that specify the angle of the bridge or water level. You can manually change the values in the topics by sliders or drop-down menus. This way you can simulate how the lock is operated. For example, you can set the angle of the drawbridge, roll back the footbridge, and open the lock. When setting the signal status to proceed, the bottom light turns green so the ship may enter the lock. When the ship is in the lock, the drawbridge and lock doors are closed and the water level in the lock is raised. In this example, we have manually set the parameters for the lock. It is also possible to import these parameters from an external data source or a log file. Here we have a comma-separated file that specify the values of the different parameters, such as the angle of the bridge, at different times. We have also added a topic that determines the position of the camera. After importing the data, we can look at the historical data for each topic, such as the angle of the bridge or the position of the ship at a specific point in time. The data can be viewed in a table or in a timeline. To play the animation, you click on the Time tab. Here you can enter a list of topics that you want to animate. You can also specify the start and end time for the data to be animated and the number of frames per second. When running the animation, the intermediate positions and rotations between the values stored in the database are calculated. Note that in this animation we have disabled the position and target of the camera. This means you can use the orbit controls to move to another position or rotate the scene to view another area. Here you see how the barriers are closed and the roll bridge is retracted. The water level in the lock is raised, the lock is opened, and the lock signal is turned to green to indicate that the ship can proceed. In the next animation, we turn on the animation of the camera. The camera has a position and a target to which the camera is pointed. The camera position and targets have been imported. The movement of the camera simulates the point of view on a ship that follows the other ship we just saw. In the data import, we have only specified a few positions of the camera. The intermediate positions are automatically calculated. Everything we have shown in this animation is created in a standard web browser using the built-in solid modeling tools, data importers, and animators. To make more realistic digital twins, you can import your own high-resolution models in GLTF or IFC format.